Hi, everyone. Welcome to the Getting to Know Google Earth Engine for Solution Challenge event. How are you doing? My name is Justin Broughton. I'm a developer relations engineer on the Earth Engine team. I'm so happy to be a part of this event today. Our team sees the massive impact and potential of the Solution Challenge, and we're excited to see the projects that students all around the world develop. It's very inspiring to hear about your journeys and what you're solving for and why. Please go ahead and share in the chat where you're joining us from today. You can click on the chat on the right and share a little bit about yourself. It'd be great to know your name and what country you're dialing in from. I know we have folks from all over the world. Today, you'll be hearing a product overview of Earth Engine, a recap of the GDSC program, and the 2022 Solution Challenge. And definitely we'll have time for questions. You can put them in the Q&A chat. Do you see the link for the Q&A? That's where you can start adding your questions. So just to recap, what is Google Developer Students Clubs? Google Developer Student Clubs are university-based community groups for students interested in Google Developer technologies. Students grow their knowledge in a peer-to-peer learning environment and build solutions. There are over 1,500 clubs in 113 countries around the world. The program has really grown over the last few years. And we definitely encourage you to join a Google Developer Student Club on your campus or one near you if you haven't already. And we do actually open up applications every year around April 1st if you do want to apply to be a leader. So that's Google Student Developer Clubs. Now, what is the Solution Challenge? The Google Developer Student Club's 2022 Solution Challenge is a competition for university students to build solutions for problems in the community using Google technology. You're invited to solve for one of the 17 United Nations Sustainable Development Goals, or SDGs for short. And today, we're going to look at how you can apply Earth Engine to your projects to tackle these broad and impactful goals. We'll look at how to use these 17 goals as inspiration and think about solving for each of these in your projects, which you can submit between March 15th and March 31st. So I'm excited to talk about Earth Engine and see how you can use it to achieve your goals with these projects. But before I get started, I want to thank you all for being a part of the community, for being active, wanting to learn, and just being passionate about technology and wanting to help your community, because that's really what the Solution Challenge is about. The goal of this is to help drive an impact in your community, whatever your community is, whether that's your school, your city, your country, global. We're all here together on planet Earth. So thank you for being a part of this, and we're all very excited to see what you build. So with that, my agenda for today is to give a high-level overview of Earth Engine, the what and the why, and then share some examples of how it's already being used to address some of the UN Sustainable Development Goals to help inspire you. And finally, I'll give you a tour of Earth Engine to help you get started using it. So what is Earth Engine? Well, the short answer is a planetary scale platform for Earth science data and analysis. But that's pretty generic, so let's dig in a little further. First, it's maybe helpful to understand why a platform like Earth Engine exists. Google's mission is to organize the world's information and make it universally accessible and useful. And Earth Engine is Google's platform for handling geospatial information, information tied to a location. There's also others. Two of them that come to mind in particular are Google Maps and Google Earth. And when I tell my family that I work on Earth Engine, they say, "Oh, I love Google Earth." And then I have to explain that Earth Engine is actually something different. I say the difference is that Google Earth is a geospatial data viewer and Earth Engine is a geospatial data calculator. And the distinction's quite great and by design. With Earth Engine, we wanted to help people make substantive progress on global environmental and social problems by empowering scientists and decision makers to generate information from increasingly large and complex data sets. And the key words there are empowered to generate information. The problems we face are complicated and nuanced. We want people to be able to run custom queries and analyses to fit their question or problem precisely. And the way we do this is by gathering and archiving hundreds of environmental geospatial data sets, which at this point totals greater than 50 petabytes in size, which is probably the largest single source geospatial data archive in the world. We attach this data archive to a massive parallel computing system and make it all available through a rich interactive interface. I like to think of it as a data reduction machine. Raw data from Earth and atmosphere observing satellites, like satellite images, as well as many derived data sets go in, and information comes out. Information that can be acted on to inform policy and optimize resource allocation and decision making. It essentially allows you to perform map-based computations, queries, analyses at speeds and scales that are infeasible otherwise. We'll get into the more practical details shortly, but first let's consider the SDGs and how Earth Engine can play a role in helping achieve them. The United Nations Sustainable Development Goals were established as a blueprint to achieve a better and more sustainable future for all people and the world by 2030. Earth Engine is well suited to help achieve these goals since they include a spatial component. Of the 17 goals, Earth Engine is particularly relevant for 8 of them that focus on more environmental aspects like growing food, access to healthcare, and clean water, developing affordable and clean energy, building sustainable communities and cities, climate action, and wildlife and land conservation. In fact, many research institutions, governments, NGOs, businesses have been using Earth Engine to make progress on these goals. So let's take a look at a few examples. Here we have an example that addresses Goal 15, Life on Land, where researchers mapped global forest extent and change over the last 20 years. Cataloging where forests are and where they are most susceptible to being lost can help with prioritizing regions for conservation, to restore or preserve habitat, and to help maintain biodiversity. In this example, a researcher has developed a data set and app that can help optimize for siting of green infrastructure. Where is it most needed in cities? This addresses SDG 11, Sustainable Cities and Communities. Next up is a data set developed by the Joint Research Center that tracks global surface water extent and dynamics for 3 decades, which supports SDG 6, targeting clean water and sanitation. And here's an example that could be used to address SDG 2, Zero Hunger. The platform OpenET uses Earth Engine to map evapotranspiration to help farmers and water managers optimize irrigation for more sustainable crop production. And here's Global Fishing Watch. This group uses Earth Engine to map fishing vessel traffic in an effort to identify illegal fishing activity and also monitor fishing pressure to enable fair and sustainable use of our oceans. This last example is pretty unique. The previous examples address SDGs of a more environmental nature, but this one addresses a social issue, access to healthcare. So a research group produced global maps of motorized and non-motorized time to reach a healthcare facility. This information could be used to optimize the location of new facilities to help ensure equitable access. So let's do a live demo of how you might use Earth Engine to begin solving an SDG. Let's use the access to healthcare dataset. Our goal will be to identify the top 10 locations globally to build healthcare facilities to make the greatest impact. Our inputs will be drive time to healthcare facilities, that dataset we just saw, and also we'll incorporate population density. Our output will be 10 small target regions as polygons, where we would advise the building of new facilities. And the analysis will include filtering the 2 data sets, 2 inputs, to the greatest need, regions where drive time is greater than 30 minutes. It takes a long time to get to a facility. And also that there are at least 50 persons per square kilometer that we want to make sure we have an impact. If there's only 1 person living in a square kilometer, it has less impact. So we'll focus on areas that are more dense. And after we have filtered the data to those criteria, we'll calculate a need score based on density, population density, and summed regional need. And from those scores, those need scores, we'll delineate 10 regions with the highest need score. Now, the place where most analyses start is the Earth Engine data catalog. So I'll head there now. If you do a Google search for Earth Engine data catalog, you'll find it, but I already have a tab open. So let's get going. So here's the Earth Engine data catalog. This is where you can go to find and explore all the data sets that are available in Earth Engine. It includes streaming satellite image data sets that include historical up to near real time that are being updated, by the minute in some cases. And there's also a lot of static data sets. Think of like elevation or population that might be a snapshot from a census and isn't updated so frequently. On this homepage, it gives a listing of some of the data sets that are available: atmosphere and weather, imagery, and geophysical. That includes terrain and land cover, croplands, and here's an image of nighttime lights down in the lower right. So most analyses start out here in the data catalog. We need something to work with, some kind of raw data to start our analysis. And we're interested in working with the accessibility to healthcare facilities data set. So to find a data set, we can go to Browse by Tags and search for keywords. You can see that there are a lot of them here. And if we type it in, it will narrow down the search to one of these keywords or multiples. So I'm going to type access. There's a tag for accessibility. If I click on it, I can see the two data sets that are tagged with accessibility. And this is the one we're interested in: accessibility to healthcare in 2019. So I'm going to click on it, and I would be here trying to learn a little bit about this data set. Does it suit my need? And I'll read and maybe want to learn about limitations to the data set, methods for how it was gathered and published, which are all really important for understanding what kind of analysis you can do and the kind of caveats that you should include with your results. So on these data catalog pages, we can find out when the data was published. We can find out who published it, how we can import it into Earth Engine. There's a small code snippet, the tags that it includes, the description, the types of information that are included with in this case, image data set. We can see that when we're looking at the imagery, the pixels, their value are in units of minute. And we have two different bands. One is accessibility, and the other is accessibility walking only. And we can read about what those mean exactly here in the description. And then also it includes a snippet of code to help you get started working with the data or visualizing it. I have a script already coded up, so I won't be using this one, but there is a convenient feature. If you click this button here, open in the code editor, it will open a new tab in your browser, and this code will be present already in that tab in the Earth Engine interface. But since I already have a script coded up, I'll just move over to that tab, and we'll get started looking at this data set. So welcome to the Earth Engine interface. This is where we do our coding. So, I had said earlier that with Earth Engine, we want to allow people to do very precise queries and analyses. And the way that we do that is by writing a set of instructions for Earth Engine's computers to run on the data set. And the way that we're doing that is we're packaging up bits of code using the JavaScript programming language. But actually, we don't use much JavaScript. It's basically all Earth Engine code. So Earth Engine has about 1,600 functions to import, analyze, and export and visualize data. So most of what we do is simply kind of coding in what you could call the Earth Engine language. So some of the components of the interface include the script editor. This is where we write our instructions for what we want to do with the data. Below it, we have the map viewer. And this is where we can draw shapes to analyze a particular region of interest. We can visualize our data analysis as image layers or as feature layers. To the left, we have our scripts panel. And so scripts that you've written in the editor, you can save them and share and manage them here in this tab. We have a documentation tab that describes all of the objects in Earth Engine. And these objects all have a set of methods, the things that you can do to them. So we've been talking about image data, pixelized data. So if I drop down this list of methods for image, we can see all of the different things that we can do with image data. And we also have an assets tab. This is where we can manage our imports and exports of image data and feature data. And then over on this right panel, we have a console where information about our queries can be printed. We can inspect the map by clicking on it. And if we export some data, we can look into this tasks tab and see how our exports are going. So let's dig into this problem a little bit in our script. So we had said that we want to identify the top 10 places to place a medical facility to increase equitability for the most at-need regions. And the two data sets that we're using for this are the time to a facility and population density. So let's just take a look at what those two look like in the map. So I have the time to access healthcare facilities, and the color here grades from dark to light, where dark is a really short time to healthcare facility and light colors are a long time. So you can see that up in the Arctic, it takes a long time to reach a hospital or clinic. And near large cities, where we see that it's dark, in more populated areas, it takes less time to reach a healthcare facility. And now let's look at population density. So here we can see that we have a gradation from dark to light, where dark is really low population density. Again, if you look at the Arctic, there's not many people living up there. And it grades to a light color, where there is high population density, lots of people living in the same area. And we can change the transparency of the population density, and we can see that there's a correspondence between drive time to a healthcare facility and population density. So this is kind of a big problem. There are lots of areas based on access time to a healthcare facility. There's a lot of areas that it takes a long time to get there. So we want to narrow this problem down. And we also understand that there's a lot of places where there's not many people living, so we can use that information to have the greatest impact. We want to be able to help as many people as we can, and be careful about the resource allocation that we have. So let's break the problem down a little bit. We can do a query that says, based on our time image, tell us all of the pixels that are greater than 30 minutes. Like, that's too long to get to a hospital. So, let's focus on those areas first. And if we look at that, we can see all of the places in purple, it takes greater than 30 minutes to get there. So these are places where we would potentially want to focus on to put a facility. But as we've mentioned, a lot of these areas are in the Arctic and in places where people aren't living. So we also want to restrict this a little bit further. And we want to say that there should be at least 50 people living in 1 square kilometer in order for us to be interested in it. So, we want to be able to make a big impact. So if we applied that kind of filter, we can see now that it's a much smaller, regions around the world where this kind of criteria matches. And so we're talking about data reduction. We're sort of reducing this problem into a manageable size. So at this point, all of these regions are weighted equally. We just know that these are areas of need, but we still want to make the greatest impact that we can in these areas of need. And we can maybe do that by normalizing this data based on, or weighting it based on the population density in these areas of need. And by doing that, we can develop a need score. So each pixel, and the pixels in this case are 1 square kilometer. So we can develop a need score for every 1 square kilometer in these areas of interest. But we also maybe want to consider a regional extent around each of these pixels to make sure that we're able to help the most people in sort of a larger radius around a given point, sort of. So to our score, or what we'll do with this score is add up all of the need within a region, and then we'll have this need score. And what we'll do is we'll find the 99th percentile, the highest need score, and we'll draw polygons around them. Well, we won't, the computers will. And then from those 99th percentile polygons of greatest need, we'll sort it by greatest need and just pull out the 10 that need the most help. And so I can add this need score, and if I zoom in to a region, it grades from light to dark purple. And so dark purple is areas of high need. And as I was describing earlier, we want to kind of aggregate this need among regions. So we'll do a moving window analysis where each pixel will be looked at, and the surrounding 25 kilometers around it, all of the need will be summed up and assigned to the central pixel. And in that way, we can incorporate sort of regional need along with the need at that specific pixel. And after running that, we can identify our top 10 locations, and they'll appear in yellow. So this is still loading. We can see that there's a load bar here, and it's almost completed. And it has identified regions in Iran, Uzbekistan, Pakistan, China, and North Korea. Also in the Sudan. So this is a little bit of a quick kind of back of the napkin analysis. And there's sort of lots of caveats here, and there's also different ways that you could slice this data and other data sets you'd want to bring in for consideration. But I just wanted to give you one quick example of how within, about 50 lines of code, we can roughly identify areas in great need of a hospital facility, and we could provide this information to, managers and government officials in these places as a place that you would maybe consider putting healthcare facilities. And once you're happy with an analysis, a really nice thing that you can do is make an app out of your analysis. A convenient way to share with people what you've found and learned and let them explore for themselves. And so we have a thing called Earth Engine Apps. And it takes essentially the script and the outputs that we have here and wraps them up into an interactive interface where there's no code showing, and users can use sliders and exploring tools to look at the data that you have generated and the analysis that you've done. So here, for instance, we're looking at a region of flooding based on, I believe, synthetic aperture radar data. On the left panel is this region of Earth prior to a flood. And then if I slide it over, we can see all this light blue, which is water, has inundated this region. So this is a nice way to allow people to quickly interact and visualize your data. Another neat example is being able to chart a location. So we'll look at ocean temperature in this example. So we can render the map data. It's still drawing, and this is happening in real time. A script has been sent to Earth Engine servers, and it's asking for ocean temperature to be colored along this gradient from dark blue to light blue, tied to the values 0 to 30. And it's retrieving them and sending them back to you in real time. And I can also click a location, and you'll see that this time series chart of ocean temperature will update for whatever region I click. And again, this is happening in real time. A request is being sent to Earth Engine servers every time I click, and the result is being sent back to the browser in the form of a chart. So a great way to wrap up your SDG solution challenge, if you're using Earth Engine, would be an app. This is a great sort of final product to deliver. So now that you've seen how Earth Engine starts, the next step for getting going is to register as an Earth Engine user. So Earth Engine is free for research, education, and nonprofit use, and you can sign up at signup.earthengine.google.com. And with your account, you get 250 gigabytes of storage, and that can include 10,000 assets. The next step is to visit our user guide. We have an extensive user guide that explains everything about Earth Engine and provides many examples of code for getting yourself started. And I also just want to mention that there is a special article in the Journal of Remote Sensing. This group is looking for papers currently on the use of remote sensing applications to address SDGs. So this is perfect alignment with the solutions challenge. So if you find that you are having a really productive, successful project, you might consider submitting a research paper to this journal. So with that, thank you, and we'll take questions.
Great. So hi, everyone. I hope you enjoyed that session. It was great information, and we hope that this inspires you to utilize Google Earth Engine for your projects. And we're so happy to have Justin here with us as well. So first, I'm going to just share my screen. I want to just introduce a little bit more about developer student clubs and the solution challenge in case you happen to find this event and didn't really know much about it. So in just a minute, we're going to have a Q&A session with Justin about Google Earth Engine. Before we do that, wanted to give a bit of context about what is Google Developer Student Clubs all about. And so essentially, these are university-based community groups for students who are interested in Google developer technologies, and students are learning in a peer-to-peer learning environment. And so this is a campus-based club. And together they build solutions. And the point of that is really to solidify any learning that you've done through events and workshops and build something together with a team. And there's actually over 1,500 clubs in over 100 countries around the world. So this is a global community, which is great. And now, you know, why we're all here is there's a solution challenge once a year. This is a competition we run annually, and students are building solutions. They use Google technology to do that. And this year we're focused on the United Nations Sustainable Development Goals. And so you just heard a bit about that. And today we want to talk about how you can utilize Google Earth Engine as well to improve your projects. And in case you don't have a Google Developer Student Club at your university campus, you can join the nearest one. You can still take part and be a part of this. You can join the nearest club to you, and I recommend reaching out to the leader of that club and asking for some help in connecting you to a team, and you can get started that way. So let's get started. I think there are some questions in the chat. As a reminder, you look at the right panel, add your questions in Q&A, and then use the general chat just to say hello to everybody. Let us know where you're dialing in from. So to get started, we did have a question we wanted to start with. So I wanted to ask Justin, do you have any advice for how I can get started using Google Earth Engine most quickly? I'm new to programming and know Python, but he or she wants a bit of guidance on that.
Sure, that's a great question. I think Earth Engine was designed for primarily environmental scientists, and a lot of them aren't programmers or computer scientists. So we tried to design the platform and the API to be user-friendly and easy for somebody outside of computer sciences to understand. I think a lot of confusion comes from, we have a JavaScript interface. We just looked at that example in the browser where you have this IDE. And so we say that that's the JavaScript interface, but we also offer a Python interface. And so I think sometimes people get wrapped up in this difference between using the JavaScript API or the Python API. And I like to recommend that people start in the JavaScript API, sort of regardless of what their programming experience is in other languages like Python, simply because you really don't use much of JavaScript or Python syntax. It's basically just a difference in defining variables. And so if you can start in the JavaScript code editor, the advantage there is that there is so much tight integration with the map for exploring the data, with the console for printing information. There is an inspector that's built in so that you can click on any point in your map and retrieve information about the data layers that you have there. So it really helps when you're first developing your code to be able to check, am I doing this right? Am I getting the results I expect? When you're working in the Python API, you have to do all of that yourself. You have to bring in an extra library, maybe like Leaflet, to view your map data. And so there's just sort of a lot more setup. So if you're just kind of getting started and want to get going as quickly as possible, start with the JavaScript code editor. If you are sort of moving into a more production mode with your analysis, then you might want to move over into Python. And also just want to say that I'll just share my screen real quick if I can. It looks like I maybe can't though. Oh, here we go. Thank you.
Sure.
That we have really good guide pages. So what we're looking at right now is the developers guide pages. And Earth Engine is an object-oriented paradigm. And so it's good to just have a good handle on what the objects are that you can work with and what the methods are available for those objects. So we have some getting started pages that kind of give you a quick overview of how to get working with Earth Engine, and there are practical scripts for each of those. But then also spend time in this objects and methods section. So this page right here kind of gives you an overview of the most common objects that you'd be working with. The majority of our data are image-based, raster-based, so it's like pixels of regions of the Earth. Each of those pixels represents some kind of attribute for what's happening on a given location. So we have single images, which might represent a date, an observation from a satellite. And then we have image collections, which represent a time series generally. So you could imagine that a satellite is collecting, observations of the same location over time. So you do a time series analysis to look at change over time. We also have geometry objects, which allow you to restrict an analysis to a region of interest. And then any reducers, that is operations for statistics. You can perform joins between data sets. So there's a lot of things that you can do, for instance, in Python with data wrangling and data analysis that you can also do in Earth Engine, but it's optimized for our system to be fast and responsive and interactive with the code editor. So yeah, start in the JavaScript code editor, get familiar with the objects and their methods. And I think once you have a feel for how Earth Engine works, it's also helpful to just do a Google search for your question. If you're stuck on something, we have a pretty active community on GIS Stack Exchange. There's about 400 questions and 4,000 questions, and about 3,000 have answers. So often if you just do a Google search, you can get a long ways, but it's good to have a basic understanding first, by going through the developer's guide.
Great. Yeah, thank you. And we have another question. Does Earth Engine support machine learning classification?
Yes, it does. So we have traditional supervised and unsupervised machine learning, like CART, random forest, SVM, k-means clustering. But we also integrate with TensorFlow for more advanced methods. And again, this is all described, in more detail in the developer guides, which I just showed, along with practical examples.
Sounds good. And what are some ways to combine Earth Engine with additional tools or technologies by Google? This is especially relevant with the solution challenge right now.
Sure. Right. So TensorFlow is a big one, which I just mentioned. Which allows you to do sort of deep learning and other advanced classification of your data. We also integrate with Colab. So if you're familiar with the Python notebook environment, Colab, Earth Engine is pre-installed in it, so you can easily import the Earth Engine API into Google Colab and interact with all kinds of other Python charting and visualization libraries. If Python is your preferred method for working with Earth Engine. And I find it's super convenient. I love doing everything in the browser, basically, and so Colab is my go-to for working with Earth Engine in Python. Also, data that you generate in Earth Engine, you can export the tiles and then import them into Google Earth as an overlay. And if you're familiar with Google Earth, it's a real stunning environment for Earth data visualization. And so if you're sharing a more finalized, polished project, that can be a good way to share your analysis is through an Earth Engine project, or a Google Earth project.
Awesome. Great. Thank you. And we have some other questions in the Q&A chat. Ayush is asking, is Earth Engine fully coded in own Earth Engine code? Sorry if I'm not reading that correctly.
Oh, well, maybe I get it a little bit. So let me just go to an example. I think, in one sec.
Sure. While you're pulling that up, just so everyone knows, in the Q&A chat, you can add any questions you have.
So I'm just back in the code editor now, and I'm looking at a script. And if I understand the question correctly, something about Earth Engine code being all Earth Engine code, and it almost is. So the only part of JavaScript that we're using here is to construct variables. So we're having to use var. If this was Python, we would just exclude var. And also the way that we define a function, right now we're using a JavaScript method for defining a function. If we were in Python, this would just be, like f. And that's sort of the only difference. And then everything inside of this function or the variables, the bulk of everything on the right side of an equal is all Earth Engine. This is all server-side code. So for instance, here we're working with an Earth Engine image, and we select the bands out of it, then multiply the bands, and then add the band. And so this is all Earth Engine code here. It's basically just the syntax for defining variables and functions that is being done with JavaScript or Python. And so these are all of the objects and their methods, and that's basically all you're working with in Earth Engine to do your analysis is our objects and methods.
Great, thanks for that. And thanks, Ayush, for asking the question. So another question, how can I integrate Google Earth Engine with BigQuery and GCP, Google Cloud Platform?
Yeah, this is an area I'm less familiar with. There are some people that are doing things with Earth Engine and BigQuery, but generally the integration is not tight. It's doing some kind of analysis in Earth Engine, usually to reduce something to a table format, and then exporting it to a cloud storage bucket, and then from there accessing it in BigQuery. So that workflow, each Earth Engine account is tied to a cloud within your Earth Engine account, you can set up a series of cloud projects or link to existing cloud projects. So right now I'm in the E.E. Broughton cloud project, and so I can write out data to, so if I had a table, for instance, I could write it to cloud storage, and then you would be able to access it in BigQuery or other Google products that can also get into a cloud storage bucket and access, for instance, a comma delimited file.
Great, and there's a lot of questions. So we answered that one. I've just signed up on the Google Earth Engine, I think, on the site. Am I good to go? What's next?
Yeah, it should be fairly immediate. It's an automated registration process. There are a few checks that happen, on your email and some of the questions that you answer. And a way to find out is to just try to visit the code editor, to see if you can get to code.earthengine.google.com. You can also just search in your browser for Earth Engine code editor, and you should find a link to it.
Great, that sounds good. And I think this is a related question, and you've answered this, but is there any roadmap to start with Google Earth Engine for complete beginners? If yes, please share or suggest one. So I know you've.
Yeah, so I think go to our developer guide pages, and you could just start on, there's a JavaScript quick start here, and that will walk you through sort of the basics of Earth Engine and get you started. You can copy and paste these bits of code into the code editor, just kind of get a feel for how it works, and how you can be displaying and interacting with the data.
Great. Thanks for that. And someone's asking, how do I create a shape file in Google Earth Engine?
Yeah, so you can, if you already have a shape file and want to work with it in Earth Engine, you can upload it through the interface here. If you go to Assets, you can go New, and you say Table Upload, and it will accept the shape file. But if you develop a new data layer, a vector-based layer in Earth Engine, you can export it as a shape file. Again, we'll go to Export, Table, and we could go to Drive. So this will put it out to Google Drive. And one of the options is shapefile.
Great, thank you. Cool, and Alif is asking, where can we access the demo code that you used?
Let's see. I can share that in, what would be the best way to share that? Can people see my chat? Yeah.
Yeah, you can post in the general chat. And also I see questions related, a few questions about, is this recorded? Yes, the session's recorded, and the on YouTube we have the first portion of the session as well. So yes, that is recorded.
So in just one second here. Another cool thing with Earth Engine is it's so easy to share code. We have a really active and inclusive user community. So when you write your script, all you have to do, if you can still see my screen, yes?
Yeah.
Is hit this get link button, copy this URL and send it to your friend or colleague, and they can see exactly what you, scripted up, and they can run it from their own account. And you can also save your scripts here, as I mentioned in the video, and easily share them and collaborate on scripts together. So that's what I'm going to do right now is I'll just copy the script from that demo and share it in the chat.
Nice.
Okay.
That's handy.
Yeah.
That's great. Yeah, thank you. Yeah, you can add it in the general chat.
Okay, so I just posted it there. So that's the script link from my presentation, the one on identifying regions with that have the highest need for hospital facilities.
Great.
And maybe just on the topic of sort of the community of Earth Engine users, if you're on Twitter, there is the Earth Engine tag, or excuse me, the tag Earth Engine, where people do their posting, and it's quite active, and it's a great place to get inspiration. People often share code snippets there. So if you're on Twitter, I would also follow this hashtag Earth Engine.
Yeah, thanks for that, and thanks for posting in the general chat the link for folks. Paul is asking, is there an open source repository for Earth Engine apps?
Oh, sort of. You can choose whether when you publish your app, whether it's public or not. And a user has just recently published a really cool way to find it. Sorry, one second. Maybe I'll just paste this link as well. Yeah, so this is a site that one of our users has put together that queries all of the publicly available Earth Engine apps and makes them somewhat searchable and breaks them down by the location that the app starts at, where it's zoomed into, and the zoom levels. Yeah, so this is my recommendation for browsing Earth Engine apps.
That's great. Great, thank you. So there's more questions. Does it cover weather data?
Yes, actually, what we're looking at here is from the GOES weather satellite. In this case, we're using it to look at a fire in California recently. But you can use this data to monitor storms. It's mostly just optical imagery So it's not going to show you like levels of precipitation, for instance. But we do also have modeled data sets. If we just browse by weather in our data catalog, there's 30 data sets. So I would recommend, exploring what's in here. A lot of them that quantify, for instance, like wind speed or precipitation, it's either historical, like it's, not real time, or near real time, or it is modeled, like projected into the future a couple days, for instance.
Cool. That's great. There's some more questions. How do I get started to share my own repos from Python to Google Earth Engine? Because I am searching a platform to pitch my ideas to the real world.
Let's see. There's some users that have developed Python packages for Earth Engine, and some of them are published on pip, and I would say a lot more are just hosted on GitHub. One that you might be interested in looking at as an example it's called GEE map. That's probably been the most successful Python sort of API wrapper for Earth Engine, and that would be a good example to go off of how they have sort of launched their library.
We'll take a couple more questions. I know we have 5 minutes left. Zainab is asking, how do I upload a file in netcdf or another unsupported format?
Yeah, you would have to use GDAL or some other conversion tool to get them into GeoTIFF format. We might have a question about this in frequently asked questions. Yeah, so here I'm looking in our frequently asked questions section, and I see, how do I upload a file in netcdf or other unsupported raster format? And the answer is currently only GeoTIFFs can be uploaded to Earth Engine. So you need to convert, and we provide an example snippet how you might convert using GDAL translate.
Great. Thank you. And then when data changes in Google Earth, is there some kind of hooks or a way to update data?
Yeah, I'm not sure if I understand the question exactly. The data catalog is live and being updated constantly. So if there's a change to the source data, generally it's, you often don't have to alter your code. The Earth Engine data team tries to make updates to the data catalog seamless. There are some instances where you do have to change your own code because something about the data has changed. For instance, right now, the Landsat satellite data is going through a collection change that's quite substantial on the data provider's end. And we can't, our users end up having to alter their code because the data provider has changed theirs so substantially.
Great. And we'll take one last question. Abdul was asking, and I think you might have covered this. What are the technologies one must know to get started on Google Earth Engine?
A real basic understanding of programming, how to set a variable, how to define a function, and how to, call on a function later. Those real basic concepts in programming is sort of the base minimum. But I would say that generally you can get there, just by digging into this JavaScript quick start guide. It will just really simply lay out for you, this is how you define a variable, for instance. And then just keep working through maybe some of the tutorials, the concepts, and learn about the objects and methods. There's hundreds of practical examples in our documentation that might get you close to an analysis that you're interested in, and that all you have to do maybe is tweak a few things. In our examples, most of them have pretty good code comments. So if you're unfamiliar with, if you can't translate the code, often there's sort of like human, readable text to describe what that line of code does.
Thank you. So we'll wrap up. Thank you all so much for joining. I'll share my screen. I have a couple more slides, and really want to encourage you to follow the Earth Engine hashtag, as Justin mentioned. So definitely follow that hashtag to learn more and get engaged with the community. And definitely thank you all for joining and listening and asking great questions. We would love to hear your feedback as well. So you might see the link. It's also tagged at the top of the chat. We'd love your feedback. We do have a feedback form. Please do share your feedback with us. And also, I wanted to just plug the Solution Challenge website. I saw a couple of people asking what the Solution Challenge is all about. It's a project competition for university students around the world. If you want to learn more, please go to that link, and students can submit projects between March 15th and March 31st. But right now you can just register to join, and then you'll get emails from us about just giving you updates and resources and invites to events like this. So really excited to see what projects you build. Hopefully you will be using Google Earth Engine as well. There's some really cool resources and things that we learned today. So thank you so much for joining us. And thank you, Justin. It was great having you here today with us. Really appreciate it. So thanks so much, everyone. We really appreciate it. We're going to leave this open just for another minute. Feel free to add any kind of final comments. Let us know what you thought. Did you enjoy the session today? You can add in the general chat what you thought about it. Thank you, Paul. Paul said very helpful. Vibob said great session. Suman, thank you. Thanks so much. Yeah, thank you all for joining, and thanks, Justin. So this was recorded. We'll be posting it, and we encourage you to register for the Solution Challenge and get some more information from us all. But yeah, thanks so much. Thank you, Justin. Bye, everybody.